Hi, so I'm going to do kth largest element in an array on LeetCode in TypeScript. And the first snag that we hit is that JavaScript does not in fact have a native heap type. Python does, it's called heap. Java and C++ do, it's called priority queue. So we have to write our own, and I don't know if this is intentional or not. My suspicion is not. So this is going to be a kind of nightmare fuel version of the roll your own heap the roll your own hash map task. Yeah, where I'm going to roll my own heap. Now, this is a nlog k problem where n is the size of the array and k is the number of elements you're going to keep. Actually, if I write this, then you'll be able to see straight away why it's this size of problem. So this is, all right, we're going to say tree array push the number, and then if tree array get size is greater than k, we'll do a tree array take and return tree array take. Right, so these are going to be log n operations because we're going through a tree of size log k, because we're going through a tree of size k, and this whole thing is log n. It'll tell you this on Geek for Geeks, but at the present time, the method that's up there does not. The method that's up there does not run in nlog k, it runs in nklog k and uses a sort, which we're instructed not to do. So I'm going to use a number of abstractions in order to create this heap. Is less than will be the first one. That will be a function. Then I'm going to create a tree array. And we will have an iterator of some sort for moving up or down the tree. We'll have a function called bubble. Equal sign there. And then there will be some sort of create tree array thing. I'll just keep that commented for now. I want to see just one compile error whenever I hit run, and right up until I'm done, so I can make small corrections as I go, because it'd be really boring having to correct the whole thing in one go. Those are my abstractions. Yeah, let's get started. So the reason I need a is less than abstraction is that we're having to deal with nulls as well as number, and a null is basically never less than. So A is less than B. Okay, so tree array. Now I could do this as a class. I can write classes when it's required of me. My preference is not to. I'm always tripping over forgetting to write this or whatever. So these will be numbers or nulls. Now I want a one indexed array because there is an elegant way of counting a tree array. Because that doesn't exist, I'm just going to stick a null in the 0 index. So this now these abstractions that I'm writing, they're not going to be pure abstractions. The advantage of having, let's array, not a pure abstraction, because I'm just going to return the underlying array and break any encapsulation. I'm doing that for speed. The advantage of having abstractions is that they're smaller pieces of functionality. They're easier to think around, they're easier to write, they're easier to debug, and hopefully they're easier for somebody who's watching to understand what you're doing, and it shows that you're thinking things through. The disadvantage is it takes a tiny bit longer to actually write, but it should be much quicker to debug. In range takes an index. N is greater than 0 and n is less than array length. And the other big advantage that we don't have here with an abstraction is you could test it separately. But here, of course, we're responsible for writing the code, and LeetCode provide the tests. So I'm taking on quite a lot here because it's all got to be tested in one go. Right, so get parent index. Number. So take the index, divide it by 2, and take the whole number. So yeah, this is why for a binary tree it's nice to use this particular counting system. So I'm just going to multiply by 2. And the right index is that plus 1. Now on to swap method. Which is much easier to implement as part of a tree array rather than to implement outside, because you can just well, we'll call that index in this case. You can just get the parent index and then yeah, compare the parent to current value. So is less than array index, comma array parent index. I'm just returning that, aren't I? No, I'm swapping, right. So here I'm returning false. Here I'm returning true. Right, so there's a reason why I don't do it like that. Value equals that. Parent value equals that. So now I just say this thing equals the parent value and that thing equals the value, and we've swapped. And we want to swap on going up the tree less than, yes, because we want the small numbers up to the top in this case. Okay, so a tree array I'm going to say is just whatever my function create tree array returns. Doing that for speed, but it's how the human brain works. You try to understand a concrete thing and then abstract it. However, and frequently when somebody's looking at your code, that's not what they're expecting to see. They're expecting you to see the types and interfaces declared first. And that's particularly important if you are publishing those types, because they'll want to be able to see at a glance whether breaking changes have been made to those types. But here it's ideal to just define the type of the tree array as whatever create tree array returns. No, the down iterator is more difficult. We'll start with the up iterator, which is a function which takes an index and a tree array. And it returns. Okay, so these iterators are just going to have a next and a swap method. And it's a Boolean. We want to know whether we've moved anywhere. So an up iterator, we just say index equals tree array get parent index of the index, and we return tree array in range index. Yeah, so as I said, the up iterator I hope is relatively straightforward. So the swap method method will it just needs to say tree array return. Yeah, I think that should work. So again, an iterator is just whatever, but create a up iterator returns. All right, let's see how we're doing. I said I was going to do one abstraction at a time. I've done 3 without checking for errors. Okay, what did I do here? I forgot to define the array as an array. Good, that's always a good start. And here I need to give an index in order to get an index, and this is a member of tree. Oh no, I'm already in the, yes, tree array. Yeah, let's try that. It's moaning about a push. Oh, why is it moaning about? There shouldn't be a. Oh, this is a heap. Yes, that's the whole point. We're creating a heap. There we go. Does that work better? Excellent. That's just the one error that I want to see. So next is a down iterator. The bubble function is particularly trivial, by the way. It takes an iterator and no, just an iterator, and we do while iterator next and iterator swap, because we've actually put most of the logic somewhere else. So create down iterator. This function takes an index and an array, same as this. Right, so we need to swap from the previous index, which means we need to track the previous index. And we need to track the left index. What we want here is the left index and the right index. And the left value, so we'll have the array. So that will just be the array of the left in the value in the array of the left index and the right value. Right index. Okay, so the easy bit is that at some point we want to say is less than left value, right value. But before we get to that point, we need to know is are these things in range? So if not true, tree array in range left value, and do the same on the right. We'll just return false in that case because we've come to the end. We're working our way down to the heap and we've reached the bottom of the heap. Else if either the right is not in range or it's less than. Let's make that a tiny bit bigger, right. Then we want to say index equals left index and otherwise index equals right index. So with a bit of luck that should be. So we're kind of homing in on this. Once I've corrected whatever I've messed up here, we've just got the heap itself left to right, and then the debugging starts. Good, just the one error. Now we're ready to define create heap. So it should be no surprise that we're going to create a tree array. And then we're going to, we need to track the size of this because it's not the same as the size of the array. The array is going to get some nulls into it. So I'm going to say size equals 0, and I'm not going to make this mistake of that, setting that to const. Right, now I'm just going to return, so we'll do the push function, and we're pushing a value which will be a number, and I'm going to say array equals tree array get array dot push value. Before that, const index equals array dot length. Push to value. Right, now we call the bubble function, and we want to bubble upwards. So create up iterator, the index and the tree array. Right, and that's it, except I'm not expecting this to work first time, so I'm going to say console log push value so we can see what's going on, and after we've done the push I'm going to say console log array. Okay, and obviously I'll take this out before I run it on anything big. So now we've got a take method which will return a number, and probably want the array again. So here the index is just 1, so we already know the result. That's the easy bit. That will be array 1. Then we set that to be null, and then we bubble in the opposite direction. So we bubble downwards from 1. log. Oh, and I haven't log here as well. Take result. Right, let's see how I've done. The function who's declared as if must return. Oh right, I've forgotten to return the result. Okay. I mean, this is the main reason that I use TypeScript and not JavaScript. It does catch silly errors like that, which would have been much more difficult to debug. We don't have no get size. Yeah, let's write a get size. Oh, not put a semicolon at the end of it. Right, and so we've ended up with a null here. I'm just going to cancel that out because then I'll be able to look at my logging and see what exactly I've done wrong. So k equals 2, we've pushed the 3, okay. Oh gosh, right. That's going to be painful. So how on earth did value 0 get a number in it? Right, so I pushed for 2. I've tried to bubble up and somehow I've bubbled all the way up. Let's have a look at the up iterator. Yes, I thought this was too simple. So we just get the parent index and ask, is it in range? And then get parent the math floor of half the index. Okay, so maybe the swap method is wrong. We're saying is our value, so is this 2 here less than 3, which it is, so we'd like to swap, so we'd want the yeah, again that looks okay. Right, and there's no need to ask are we in range because that's already been done, except for some reason we're not in range. Okay, what does in range? Yeah. Right, but there's no guarantee that the parent index is in range. Okay, so that's how we end up in that little null value that shouldn't be there. So let's say tree array in range parent index. Does that help at all? good. At least we got the wrong answer, but at least we have there. Right, so we pushed a 1 here and it didn't rise to the top. That's the first mistake that I can see. So the parent would have been 3 and we don't want that 3 to be taken. Right, and it's not that we've reversed the sort. Okay, so I'm going to look at the down iterator then. Am I going to? No, there's a push. It's the up iterator that's at fault still. We've pushed a 1 and it hasn't risen. Bubble function is simply saying next and swap. So oh, I've got this wrong. The down iterator doesn't count. The up iterator cares about what its previous was, and the down iterator doesn't, I think. Let's try that. So somewhere, of course, the other potential problem is that I'm not setting the previous when I change the index. Oh, am I even changing the? Yeah, I'm changing the index there. So I would have had, if I was going to do the previous, it would have to have been there. Yeah, let's try that. So prev equals index, and we'll swap the previous. How am I doing? There's always a bit when you finish writing a program where nothing works and I don't know what's going to happen. Right, I mean, this push looks good to me. I think the smallest numbers are rising to the top now, which is what I want. So presumably it goes wrong when I start taking. Yeah, that take. So why did this end up? We've taken the 1 and yet we end up outputting a 1. That's... Oh, right. So the final take was of a 1. So oh, we've only taken once. Something's very odd there. So maybe it's not getting the size properly. No, it's not getting the size properly. I'm simply not mapping the size. I shouldn't be at all surprised that this has gone wrong. Let's try again. Okay, that's looking better than it was. So output 6, expected a 5. Yeah, why did it? We took the... We took the 4 and then we took the 6. So right at that final hurdle, it was looking, saying, shall I take this 5? No, the push went wrong here. So I pushed the 4 and it rose to the top. Yeah, then we take the 4 and it says, no, but yeah, that null appears there, which we don't. Or is the 5 underneath? The 5 is underneath the 4, which is no. There's a There's a 6 and a 4. Sorry, there's a 6 and a null underneath the 4, and then underneath, and the 5 is underneath the 6, which it shouldn't be. Where did the 5? So the 5 was there, and then the 6 was pushed, and it's right. So I don't know where this problem is. This, I've also got a build up of nulls, which I don't really like. Might even be violating the order of magnitude that I promised, but it's not essential that I deal with that to pass this problem. So I took the 1, I had to 2 with a 3 and a null underneath it. Still got. Right, so the 5 is under the 3, which is good. 2 gets taken, the 3 rises up, the 5 doesn't. Okay, so we are bubbling up. No, we're bubbling down because we've taken the 2 and something didn't quite work, something to do with a null. So we're asking, is the left value less than the right value? And if it is, we want the left value, otherwise we want the right value. And a null will, a null is never less, a null will stay at the bottom. Yeah. Oh, right. These tests are wrong. We're testing as a value in range where it should be the index that we're testing. Good. Let's try that. Right, excellent. That's not too bad, is it? So, I'm going to take my logs out now. There should be 4 places where I'm logging things. And submit. Right, and I don't expect it. I expect this to perform acceptably, but not compared to not compared to a native heap type. Anyway, so that we're done. That is the lowest, the kth largest element in an array. Thanks for watching.